Let us look at quadratic equations in more detail. A quadratic equation is an equation whose degree is 2 and in general form is written as ax square plus bx plus c equal to 0, where a and b are the coefficients of x square and x respectively, and c is the constant. Since c can be written as c x to the power of 0, we can say c is a coefficient of x to the power of 0. Now, in a quadratic equation, ax square plus bx plus c equal to 0, a is not equal to 0. Then if a is less than 0, that is negative, then the parabola opens downwards. And if a is greater than 0, then the parabola opens upwards. Px is the linear term in the quadratic. Now, if b is equal to 0, then the linear term disappears and the equation is called a pure quadratic or depressed quadratic. Quadratic equation has 1, 2 or no real roots. This means there are at most 2 points where the graph intersects or touches the x-axis. The formula for finding the roots of the quadratic equation is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. This is called the quadratic formula. Unlike a straight line, the slope of a quadratic curve changes continuously. We look at the slope at a point as the slope of the tangent line to the curve at that point. Okay, so let's draw the graph and see. So let's draw the graph of ax square plus bx plus c, where a is 1, b is minus 1, and c is 1. So here, if you notice, it is above the x-axis. And since the coefficient of x square is positive, that is greater than 0, the parabola opens upwards. Now let's make a negative. So if we make it negative, do you notice that it opens downwards now? Okay, let's make b 0 so that it disappears. So it has become 0. So we have minus 1.5 x square plus 1. As far as the quadratic formula is concerned, basically this gives us x values where the curve intersects the x-axis. So we have 2 points where it is intersecting the x-axis. So if we evaluate this formula, we will get 2 values of x. X equal to something here and x equal to something here. So let's make it more precise by taking specific value for, let's say, let me make it 1. A is equal to 1. So now this will not give us x values in real numbers because it is not intersecting the x-axis. Now let's make it minus 1. Now this formula will give us 2 values of x where it intersects the x-axis. When a is equal to 1 and c is equal to 0, then the quadratic formula will give us plus or minus 0, plus 0 or minus 0, which points to the same point. Okay, now as far as the slope is concerned, we take a point anywhere on the curve and we draw a tangent. Then the slope of this parabola is equal to the slope of this tangent at this point. That means the slope will keep changing as I move that point. Nice to know that the slope of the quadratic ax square plus bx plus c at any given point on it can be evaluated using 2ax plus b. So you use this formula to arrive at the slope of the tangent line at this point. That means it is the slope of the curve at this point. A pure quadratic is symmetric about the y-axis. So what does that mean? Here we have a pure quadratic because the linear term is not there. So here you notice that this parabola is symmetric about the y-axis. It is also called depressed quadratic because it is missing its neighbor, that is the linear term on a lighter side. So that was quadratic equations part 1. That's it for now.